Hi students, here we are discussing about the binomial distribution tends to normal distribution. As n becomes large, that means n tends to infinity, neither p nor q is very small. Binomial distribution is a discrete distribution with parameters n and p. As n tends to infinity, it tends to normal with parameters with mean np and standard deviation root of npq. We know that the binomial distribution has mean np and variance npq. So the standard deviation is root of npq. Okay, here in order to prove this result, as binomial tends to normal, binomial is a discrete distribution and normal is a continuous distribution, but as n tends to infinity, and the next condition is neither p nor q is very small, then binomial tends to normal. Here we are using the result of using the MGF technique to determine the distribution of. First we are transforming, we are writing this as y equal to x minus np divided by root of npq, where x follows binomial with parameter n and p. This is x minus its mean np divided by standard deviation. We have already studied in binomial normal distribution. If x follows normal distribution, x minus its mean by standard deviation that follows standard normal distribution. X minus its mean divided by standard deviation that follows n01. Here instead of binomial normal distribution, here we are using the mean of binomial distribution and standard deviation of binomial distribution, and we are using the MGF technique to determine the distribution of y. Where x follows binomial np, we know that the moment generating function is q plus p e raised to t the whole raised to n. The MGF of binomial distribution. Next, we can find the distribution of y by writing myt is equal to my is x minus np by root of npq of t. That is equal to, we can write this as x by root of npq minus np by root of npq. Okay, we can write here x minus np by root of npq. We can write this as x by root of npq minus np by root of npq. Now this is of the form ax plus b, where a is x, coefficient of x, that is 1 by root of npq, and b is minus np by root of npq, minus np by root of npq. So we are applying here, we apply the property of MGF. We can write this as e raised to max plus bt equal to e raised to bt. That means e raised to, b is here, minus np by root of npq. Then e raised to minus npt by root of npq. We are writing e raised to bt into mxat, where a is 1 by root of npq, then 1 by root of npq into t, that is t by root of npq. Then we can write this as e raised to minus npt by root of npq into, we know mxt is q plus p e raised to t the whole raised to n. Then mxt by root of npq is, instead of t, we have to substitute t by root of npq. Then we can write here as q plus p e raised to t by root of npq the whole raised to n. This is now in e power, and this is also q plus p the whole raised to n. The power is here, so the calculation is difficult, the simplification is difficult, so we are taking logarithm on both sides. Then it becomes log myt is equal to log e of this one is equal to minus npt divided by root of npq. Then product of 2 we can write as sum of the logarithms. Then plus. Then logarithm of term raised to n we can write n times logarithm of this one q plus p e raised to t by root of npq. Okay, for example, log x raised to b we can write log x raised to b we can write b log x. Using this result we can write this one n log this one. Okay, then in order to solve this expression we are using the formula, we are using this equation e raised to x. We know that e raised to x equal to 1 plus x by 1 factorial plus x square by 2 factorial plus etc. So log myt we can write as this minus npt divided by root of npq plus n times logarithm of q plus p take outside, then e raised to this one. Instead of instead of x here t by root npq is here. Then 1 plus instead of x t by root of npq divided by 1 factorial, it is 1 plus then x square, that means t square by square will come root will come out, then npq by 2 factorial. 2 factorial is 2, so we can write here 2 npq plus then the next term becomes tq by 3 factorial into root of npq the whole cube. Root of npq the whole cube means we can write as npq all raised to 3 by 2. That means n raised to 3 by 2. Order of n raised to, we can write this as plus order of 1 by n raised to 3 by 2. Instead of etc, because we are substituting as n tends to infinity. As n tends to infinity, it tends to normal. Then n tends to infinity we are applying, so then remaining terms become 0. That's why we are not writing all the terms. We are writing, we need only this much term. The remaining terms will cancel because 1 by n, we know that as n tends to infinity, 1 by n tends to 0. So the remaining terms become 0. So we are writing the remaining terms, all these terms we are writing order of 1 by n raised to 3 by 2. Okay, then we can write this as minus npt divided by root of npq plus n of logarithm of q plus p into 1 we can write p plus p into t pt divided by root of npq plus pt square by 2npq plus order of 1 by n raised to 3 by 2. This is equal to minus npt divided by root of npq plus n logarithm of, here q plus p is here. Q plus p is, we know that for a binomial distribution q is 1 minus p, then 1 minus p plus p is equal to 1. Okay, then q plus p is 1, then we can substitute q plus p is equal to 1, then pt divided by root of npq plus pt square. Sorry, here p and p are here, we can cancel this p, then t square is here, t square divided by 2nq, 2nq plus order of 1 by n raised to 3 by 2. Then this is equal to here logarithm of this term. Okay, have studied logarithm of 1 plus x. We can write as x minus x square by 2 plus x cube by 3 minus etc. So here logarithm of 1 plus x, x is this term. Okay, so we can write this one as log myt is equal to here minus npt by root npq is here minus npt by root of npq plus n of here x is this one. So we can write in bracket pt divided by root of npq plus t square by 2nq plus order of 1 by n raised to 3 by 2. Okay, then next term is minus this term whole square. What is this one? X square divided by 2. That is pt divided by root of npq plus t square by 2nq plus order of this term. Then etc. We can write this also as order of 1 by n raised to 3 by 2. Because the other terms may vanish if you are substituting as n tends to infinity, the other terms vanish. So we can write this as minus npt divided by root of npq plus from here it is n into pt divided by root of npq. You can write this as npt by root of npq plus next term is n into t square. N into t square divided by 2nq will cancel this term. Plus if you are cancelling order of 1 by n raised to 3 by 2. If you are multiplying with n, it may order of 1 by n raised to 1 by 2. Minus here 1 by 2 of this term. What will look at? If you are squaring, it is p square t square divided by npq plus here t raised to 4 by 4 n square q square plus a square plus b square plus 2ab plus 2bc plus like that plus etc. The other term there is no need of writing the other terms because all here if you are multiplying with this n will cancel and this n square 1n will cancel and here order of 1 by n raised to 3 by 2 is here. That means 1 by n raised to 3 by 2, the term of 1 by n raised to 3 by 2 and the next term will be 1 by n square and the next that is 4 by 2, that is n square and the next term is order of 1 by n raised to 5 by 2 like that. If you are multiplying this it will start with the 1 by the term of 1 by n raised to 1 by 2. Okay, then if we are doing this, we can write this here t square. We can take t square by 2q from this common. Then here 1 minus p minus t raised to 4 by 8nq square plus a power of 1 by n order of 1 by n raised to 1 by 2. Then t square 1 minus p is q. Then we can write t square by 2q into q. T square by 2q into q minus t raised to 4 by 8nq square plus order of 1 by n raised to 1 by 2. You can cancel this q. Then as n tends to infinity, as n tends to infinity, log myt is equal to if we are substituting n as infinity, here there is no n term. Here we can write t square by 2. Here n is here, 1 by infinity is 0, and here all the terms will vanish if we are substituting as n tends to infinity. Then log myt equal to t square by 2, or myt equal to e raised to t square by 2. That is, this is the MGF of standard normal distribution. That means y follows normal with the mean 0 and variance 1, or standard deviation 1. This is the MGF of standard normal distribution. We have started from the MGF of binomial distribution with the parameter n and p, and we are substituting y equal to n minus y equal to x minus np by root of npq. Then as n tends to infinity, this distribution tends to the MGF of standard normal distribution. Okay, then what is y? Then what's our y? Y is equal to x minus np by root of npq. That follows n0 1 as n tends to infinity. Y equal to x minus np by root of npq follows n0 1. Or we can write this as x follows. If you are writing as x, it follows normal with the mean np and standard deviation root of npq. If you are writing the variance, it becomes npq as n tends to infinity. This is the condition for binomial tends to normal as n tends to infinity, but the mean and variance change, mean as np and variance is npq, or if you are writing np and standard deviation, it is root of npq. Okay, thank you.